multiplication any number of times without the encryption breaking down. Hi everyone, today's video is on homomorphic encryption. Before we dig deep into that exact topic, let's do a quick talk on encryption in general so that we all have a solid foundation. So encryption is the process of turning readable data, which is called the plain text, into an unreadable format, which we call the ciphertext. If I give an example, say you want to meet a friend today and you want to send a message saying, meet me at 5 p.m. But without encryption, everyone who sees the message can read it, right? But if you encrypt it, it will be transformed into something unreadable, like a random set of characters, which is like totally unreadable. So only you and your friend who has the decrypt key can unlock it and then turn it back into the meaningful format. So this method is important for protecting sensitive information like your passwords, bank details, or maybe personal messages and so on. So without that, all the valuable information that we have can be intercepted by someone who has malicious intentions. So encryption is like a way of keeping our information safe and private, especially if we're sending it over the internet or storing it in public places where others might try to steal it. Guys, so now you all know what encryption is, right? So let's move on to the more advanced format, which is called the homomorphic encryption. So homomorphic encryption is like a special kind of encryption which allows us to perform calculation on our encrypted data without having to decrypt them. Let me put it simply. So like say we work on our encrypted data just as if it is not encrypted, just as it's still in the readable format, but without exposing the sensitive information it has. So if I give an example, say you have a bank balance stored as encrypted data and you want to calculate the total balance after you put a deposit. And usually we would decrypt the balance first, do the math, and then we would encrypt it again, right? But with homomorphic encryption, you can directly add the deposit to the encrypted balance. So when you decrypt the result, you get the same outcome as if you had done the calculation in that original readable format. So this means that you can keep your data private and secure while actually being able to process that data for any type of analysis, or we can also run complex algorithms or do calculations based on that without actually exposing what that data holds. That's the main idea behind homomorphic encryption. So I hope you got an understanding on that. So let's see the different types of homomorphic encryption. So just like encryption, it has different type of methods and level of security. Same thing here, homomorphic encryption also comes in different types, and the types vary based on how many operations you can perform and how complex those operations can be. So the main three types of homomorphic encryption are partially homomorphic encryption, somewhat homomorphic encryption, and fully homomorphic encryption. And I'll give a brief explanation to each one of these three, okay? So with a partially homomorphic encryption, we can only perform one type of operation on the encrypted data. So you can either add or maybe multiply, but we can't do both on that data. Think of it like having a calculator that has only add or multiply, just one of those two, but you can't do both at the same time. So in somewhat homomorphic encryption, uh, this is like a combination. It allows both addition and multiplication, but only a limited number of times you can do those operations, right? So you can add and multiply some numbers on the encrypted data, but after a certain point, it becomes too complicated and you will have to decrypt it to continue. So the next one is fully homomorphic encryption, and this is like the most powerful type because it lets us perform both addition and multiplication any number of times without the encryption breaking down. So this is like the best privacy preserving computation because it allows full unlimited processing on that encrypted data, right? I'll give an example for FHE. You can perform multiple calculations like adding, subtracting, multiplying, or even more on the encrypted data, and no matter how many times you do it, the result will always be accurate once you decrypt it. So now that you know about the types of homomorphic encryption, let's have a small talk about the real world applications where we can use this technology to make an impact. The first one that, there's a lot, but I've only chosen two. So the first one is in cloud computing. So here we store and process data on remote servers, right, rather than our personal computers. So while this is very convenient, we also have this privacy issue concern. So because we're trusting third-party cloud providers with our sensitive data. So homomorphic encryption solves this problem because, like I said before, we can encrypt our data before we send it to the cloud. And the cloud will perform the calculations on that encrypted data without seeing the actual content. So if I give like an example, if you want to analyze a personal data that you don't want to show anyone or run some computations on it, then the cloud provider will not have access to your private information, but it will work on the data and you will get the results. And you can decrypt the result and then you can get the answer, but no one actually sees the raw data, right? So that's the advantage of it. So the second one that I've chosen is machine learning. This is where algorithms learn patterns from large data sets to make predictions, right? So machine learning models are very powerful, but sometimes they need access to large amounts of sensitive data, which is a huge security risk in a practical scenario. So with homomorphic encryption, sensitive data can be encrypted and machine learning models can still be trained and tested on that encrypted data, which means that organizations can run machine learning algorithms without exposing the private data to anyone, including those engineers who are running the algorithms. This is all for my first video on homomorphic encryption. Next video will be on the differences between FHE and PHE. I hope you all understood a little bit on this topic because it's a little bit deviated from the content that I usually do. So if you all have any questions, drop them down in the comment section and I'll be answering. Thank you.